a few more problems from our note sheet. So, it seems to me that I stopped with question number 5, which is on the back side of 60. I mean, I need to start with question number 5 on the back side of page 60. Okay? Now, the sub reported that you did not necessarily use your time very well on Friday, and she indicated that many of you still need to watch the video. Now, I don't know, maybe there were Wi-Fi issues. Second period, there didn't appear to be Wi-Fi issues any other period, but maybe there were.
All right, that makes it really
But
bad.
now you go home. Now you go home where you have good Wi-Fi, and you watch the videos. Okay? Period. Okay? You wasted a period on Friday. You give me that period back. Now it'll have to happen at home or during resource or something like that. All right, number 5. Here we go. Everybody's got your notes out. And we are going to look at question number 5. It says draw a Venn diagram. Okay, here we go. I drew it for you, basically. Now, the given says the probability of A is 0.6. Now, you may not be familiar with that notation, so I'm telling you what it is right now. It says the probability of A is 0.6. The probability of B is 0.5. And the probability of A and B, this means and. You learned that in geometry. That's called the intersection symbol. It means and, overlap. The probability of A and B is 0.2. Now, your job is to put those numbers into this Venn diagram. All right? You can do that. That's pretty easy. Start here. Always start right here. These are the overlap people. Abby Brady, pick up your stuff, come in and sit down here. The probability of A and B is 0.2. That means this little piece of the picture right here is 0.2. Because these are the people or the things that are in the A circle and the B circle. Do you see that? Now, the entire A circle is 0.6. Where are we going to put the 0.6? Nowhere. You're not putting 0.6 in this picture. What are you going to put in instead? 0.4 right here. The whole circle is 0.6. But 0.2 of them are already there. So 0.4 of them here. The total is 0.6. Does everybody understand that? The total A circle is 0.6. Now, the total B circle is 0.5. So what's this got to be? 0.3. Now I want you to look inside that Venn diagram. You got 0.4, 0.2, 0.3. What's that add up to? 0.9. Wait a second. Probabilities are always supposed to add up to 100, 100, 1. So tell me, if I only have 0.4, 0.2, 0.3,
0.1 was nothing.
the 0.1 is out here. So in other words, think about it in terms of a situation. Let's suppose A is the people who like
Peanut butter.
Peanut butter. And B is the people who like
Jelly.
jelly. Okay? So you've got 20% of the people that like peanut butter and jelly. You got 40% that like only peanut butter, 30% that like only jelly, and what about these guys?
They don't like that.
They don't like either
They
one.
just nasty.
That's right, they don't like either one.
They just
Now we're
nasty.
going to answer the questions. Here we go.
Oh. They just nasty.
Look at this notation. This is crazy.
It's crazy.
All right, so here we go. This says, if we go back to our peanut butter and jelly, find the probability or find the people who like peanut butter but don't like jelly. This little notation means not. So you are in the A circle, but you are not in the B circle. All right, look at your picture. You're in the A circle, but you're not in the B circle. Isn't that these people right here?
Mm-hmm.
So the answer would be 0.4.
So the dash means not.
What?
The apostrophe
Means not. Yeah, that's the notation for it. The actual mathematical word for it is complement. It means not be. All right, now what's this? This is the people that aren't in A, but they're in B. So who is not in A, but in B? 0.3? What does this mean? That's you're not in A, and you're not in B. You don't like peanut butter, and you don't like jelly. What's that? That's 0.1. Good job. Will?
I don't have to get a dumb question, but how'd you get 0.3 and D again?
Because the total B is 0.5.
Okay.
If 0.2 of them are already here, this whole thing's B, Will. If 0.2 of them are already here, then there's only 0.3 to be left. Okay, now we're going to try another one. Okay, Maya Brownlow, you paying attention? Yes, ma'am. Now, it says the probability of C is 0.75 and the probability of D is 0.4. And the probability of C and D, remember this means and, C and D is 0.35. So where do I start? I told you in the last problem, where do we always start? With this. Where do I put that 0.35? In the football.
Football.
Now, this is the whole C circle right here. That whole circle is 0.75. But you've already put 0.35 in there, right? So what goes here?
0.4.
0.4. This is the whole D circle. The whole D circle is 0.4, but you've already put 0.35 in there. Now what does that add up to? 0.8? What does that mean? There's 0.2 on the outside. So if these are the people that like pancakes, and these are the people that like waffles, then these are the people that don't like either one. Yeah. Yeah. All right, let's answer the questions.
Just like your father.
Okay, what is the first question asking for? What does that say?
Why is it using
Find the
D?
probability of
Was it B?
C. Oh, I have no idea.
It's for you told me all 3 times.
I'm sorry. Did I put B in here?
Yeah.
I'm just goofy. Okay, so what does this say? Find the probability of being in the C circle, but not in the D. So what's the probability of being in C, but not in D? Isn't that this right here? It's in C, but it's not in D, so that'd be 0.4. What's the probability of not being in C, but being in D? 0.05? You want to be in D, but not in C. You want to be in the D circle, but not in the C circle. So that's only these guys, 0.05. What does this last one say? Not in the C circle, not in the D circle. So what's the probability of not being in either one?
0.2.
0.2. Those are those leftover people that don't like. Patrick?
What if there's no like option, like C and D, would that be the middle one, or would that be like total?
Now, if it said C and D,
Yeah.
that's given. That's the middle. That's what's in the middle. All right. One more page. This is called, we're going to switch gears now. This is not a Venn diagram. This is called conditional probability. And it's actually quite easy. Okay, everybody read problem number 7 on page 61. Katie, did you read problem number 7? Now, all right, so here's the deal. This is called conditional probability because Joe's going to do his homework. The probability of Joe doing his homework depends on what? The weather, whether it rains or not. So let's start with that. Tomorrow, it is either going to rain or it is not going to rain. That's what's in charge of everything. That's what's going to determine whether he does his homework or not, is the weather. So start with the weather. It's either going to rain tomorrow or it's not going to rain. Now, what's the probability that it will rain? So I'm going to put 0.3. Are you comfortable with that? 30%, 0.3? And then if there's a 30% chance that it will rain, there's a 70% chance that it won't rain. Now, either way, we're going to talk about Joe doing the homework or not doing the homework. Either way, he's either going to do it or he's not going to do it. So I'm building what's called a tree diagram. And the first level of the tree is the weather. The second level of the tree is the homework, because the homework depends on the weather. Now, if it rains, be careful, you gotta read carefully. If it rains, what is the probability of Joe doing his homework? 40. So I'm gonna put 0.4. Then what will this be? 0.6. Remember, the probabilities have to add up to 100. So if the probability of him doing it is 40, him not doing it's going to be 60. Now what if it doesn't rain?
Then it's not 10%.
10% he will, and 90% he
No.
won't. Are we comfortable with all the numbers in the tree now?
Oh yeah, I'm feeling with it. I'm feeling it.
Now I want you to multiply each branch of the tree. So in other words, if it rains, he'll do his homework. That probability is 0.12. How did I get 0.12? I multiplied 0.3 times 0.4. Now, what about rain and no homework? What's that probability? Rain and no homework, 0.18. How about no rain and homework? 0.07. And rain and no homework, or no rain and no homework would be 0.63. Now the question is, find Joe's probability of doing homework. Now, there are two ways he can do homework. He can do homework if it rains, and he can do homework if it doesn't rain. So you have a 0.12 and a 0.07. What do you think you're going to do with those two numbers? Add them, because he's going to rain or not rain. We're going to do homework here or here. So we add those two together, and the answer is 0.19.
That was crazy.
Well, the good news is, Rob, is we have another one.
I can like predict everyone's future.
If they say me, you go, no, if they say my parents, you go,
0.19.
last night.
Probability of doing homework there, plus the probability of doing homework here. Yep.
What was in this?
Should last for like 10 minutes. Then I got
Okay,
Snapchat.
number 8.
It's
If the cafeteria serves noodles, there's an 80% chance they'll serve salad. If they don't serve noodles, there's a 50% chance they'll serve salad.
Noodles.
Given that they serve noodles just once each week, find the probability that they'll serve salad. Okay, what am I going to start with on my first branch?
Salad or noodles?
Which one? Noodles. We're either going to have noodles or we're not going to have noodles.
We gonna have us some noodles.
Now, what's the probability on any given day we're going to have noodles?
20%.
20%. Jerron, you want to explain that?
Because 80% of the time it's salad, which means 20% of the time has to be noodles.
No.
Wait, but no, well, I mean 80.8.
No.
There's
Stop.
5 days in a week.
5 days in a week, exactly, Maya. The problem says that we serve noodles 1 day a week. There are 5 school days in a week, so 1/5. 1/5. So 20%.
Wait, rewind. So how was my logic wrong then?
Okay, we're not there yet.
Oh.
So, because this has nothing to do with salad. So all your conversation about salad, we're not there yet. We're talking about just noodles. And we have noodles 1 day out of 5. So there's a 20% chance we'll have noodles and an 80% chance we won't. Now, we're either going to have salad or we're going to have no salad. All right, now, if we serve noodles, what's the probability we're going to have salad? If we serve noodles, what's the probability we'll have salad? 80. What's the probability then that we won't have salad? 20. Now, what if we don't have noodles? If we don't have noodles, then what's our probability of salad? 0.5? And not salad will also be 0.5.
So these are being served at the same time?
Yes.
Okay, got
Yes.
you.
But the salad depends on the noodles.
Got you.
All right, what's the probability of this branch? Remember, you multiply on the branch.
0.16.
So 0.16. This one would be
0.4.
.04. This one would be 0.4, and this one would also be 0.4. Find the probability we'll serve salad.
You have to add up 0.16.
Katie Roth, what are you doing? Find the probability we'll serve salad. Well, we can serve salad here, right?
Yeah,
And we can serve salad here.
yeah.
So what am I gonna do with 0.16 and 0.4?
Add them.
So the answer is?
0.56.
Got it, 0.56. One more. So the probability we play lacrosse if he plays soccer, probability he plays lacrosse if he doesn't play soccer, find the probability of a student playing soccer, or if the probability of a student playing soccer is 70%, find the probability he plays lacrosse. What do I start with?
I'm saying soccer.
You would start with soccer, because doesn't the lacrosse probability depend on whether he plays soccer?
Yep.
So we start with the thing that doesn't depend on the other one. So soccer's what we start with. So we're either going to play soccer or we're not. What's the probability that somebody plays soccer? What's this? It says right in the problem. Wait a minute. No. Just play soccer. It tells you in the problem. Karen? 0.7. You guys, the last sentence says, the probability of a student playing soccer is 70%. I can't help you if you don't read. It says it, it's 70%, which means the probability of not playing soccer is 30, because they add up to 100. Now, we're gonna play lacrosse, or we're not gonna play lacrosse. Now, if we play soccer, what's the probability of playing lacrosse?
62.
That's your 0.62. If the probability is 0.62, we will play. What's the probability we won't play?
48.
38. The probability he plays lacrosse if he doesn't play soccer is 48. And then not lacrosse would be 52. Now, each branch, here we go. This first branch is 0.7 times 0.62, 0.434, 0.7 times 0.38, 0.266, 0.3 times 0.48, 0.144, and 0.3 times 0.52, 0.156. Now we need the answer to the question. So what is the ultimate question? Find the probability he plays lacrosse. That would be this branch right here, because it ends in lacrosse, and this branch right here, because it ends in lacrosse. So when I add those together, 0.578. Anybody confirm?
That looks about right.
Okay, so now what I want you to do, did anybody do last night's homework? Anybody have a question about it? Maya, did you have a question about it?
Yes, I actually have several questions on the
All right, honey, I'm so glad you have questions. Tell me what page and problem number they are, Maya.
Are you surprised? I know I did.
Maya, you want to graduate from
I mean,
college?
Miss Ford, I mean, that's what we hear. As long as you
You are
know,
on the right
as long
track.
as you know that.
So tell me which page and problem number you want me to do.
Okay. I don't really know what page it was on, but 25 on 9.3.
28.
Yep, 728. Okay, I'm missing Jonathan,
What's up?
Dane,
I do it every day, first period.
Every day.
Noel.
Yeah, swear down.
Even though you're working every day.
Everybody else is
Like, it's like, you have to do it, so I can copy it. And she made that, we end up writing her birthday. She put 20.
Okay, which word did you say?
25.
Why are you trying to rip off their tab? Okay. Would everybody take a look at problem number 25 on page 728? This is a little bit wild and wacky. Okay. This is not a normal situation. This deck that you're playing with, Maya, has only 24 cards. And the only cards in it are the aces, king, queen, jack, and tens, and 9. Okay? So Maya, there are a total of 24 cards, and there are 4 of each of these. Same suits, so you've got diamonds, spades, clubs, and hearts, but you're not playing with all the other cards. You're playing with only the small deck of cards, okay? And it says, these are 6-card hands. So this is just a weird situation. You got 24 cards, and you have 6-card hands. Now we want, you said 25, so we want the probability of all 4 aces. Okay, I need you to think about this for a minute. It's a 6-card hand. 4 of them are going to be aces, which means what about the other 2?
They're gonna be anything else.
They're going to be anything else. They're going to be not aces. So you're going to pick 4 aces and 2 anything else. Okay? Now, how many aces are there in the deck to choose from? So that would be 4C4. There's only 4 aces, Maya, and you need to pick them all. Now, how many other cards are there? If we take the aces out,
20.
there are 20, and we need to pick 2 of those. This is a 6-card hand. 4 aces, 2 not aces. Where did this 4 come from? There's 4 aces to pick from. You're picking all 4. What's this number? The total number of cards left, not aces, and you're picking 2. Now, Maya, that needs to be divided by 24C6 because probability is what you want over the total. How many total cards are there in this deck? 24. How many total cards are you choosing? 6. That's your denominator. So these 2 get multiplied together, and then you divide by this one, and that will be your answer. Shall we do another one of those?
Yeah, can you do 26?
Is that a card problem?
Yeah, the last one.
Okay.
Yeah.
Okay. So,
Press, smash, and then go over to.
okay, so a hand includes 2 jacks of the same color, called the left and the right bower. Okay. So, there are actually 2 things that can happen in this problem. I'm moving on to problem 26. You could get 2 black jacks and 4 other cards, right? Or you could get 2 red jacks and 4 other cards. Now, are you reading question 26?
Yes.
Does that make sense to you?
Yes.
That you're going to get either 2 black jacks or you're going to get 2 red jacks? Do we care about any of the other cards we get?
No.
Nope. How many black jacks are there in this deck? 2, and I need both of them. How many not black jacks are there in this deck?
22.
22, and I want 4 of those. So here are my 2 black jacks. I'm picking both of them. Here are my 22 not black jacks, and I'm picking 4 of them. Oh, this is a tough problem. I will never ask you anything this tough.
You're being serious?
Huh?
You're being serious?
Yeah, because the next part's easy. That would basically be the same thing, wouldn't it, for 2 red ones? Here is where it becomes tricky. In this scenario, remember, these are the 2 black jacks, so they're taken care of. And this is 4 of any other card. Could this actually include 2 red jacks also?
Yes.
Okay. Over here, this is the 2 reds. Could this also include the 2 blacks?
Yeah.
So I have actually counted that situation twice. This is 2 black, 2 red, could include it. This could include 2 black, 2 red. So now I need to subtract that probability out. This is way more than I should have read it more carefully. Don't worry about this problem. This problem will not be on your test. Now, this one might be.
Can you put that in calculator? Guys want to know like if I like got it right or not.
What did you get?
0.00141168. And like, do you stop at
0.0014?
Yeah. Do you just put 0.0014 as a restart?
Yep.
Okay.
Good job, Maya. Yes, Patrick?
23 and 24 is same.
Yes, they are. They have to be.
No. 23 and 24 are very closely related, but 23 says specifically all spades. So all spades, now remember it's a 6-card hand, and you would have how many spades in this deck? Just 6, right? Okay, so that would be 6c6, 6 spades, take it 6 at a time, over 24c6. Okay, that's all spades. Now, when it says all the same suit, that would include not just all spades, but how about all diamonds? Now, what would the all diamonds fraction look like? Same thing, and all clubs, and all hearts. So it's this times 4. That would be same suit, because there are 4 suits that all have the same probability.
Could we also just solve it and just multiply the answer by 4?
Yes. Yes. Do you understand that, Patrick?
Yeah.
Yeah.
Yeah, I thought it was the same exact
I did too. I was like, oh, it wasn't it was fine.
All right. Anything else? Did someone say it's their mom's birthday today?
Should be a birthday bonus.
It's my mom's birthday today. Right, anything else? Taylor? No, we did it for practice, I'm sure you weren't here.
Miss Ford, since I'm going on retreats, can,
Tell
you
Miss
give me
Ford
some
to
math
turn that off.
classes? I am bringing my math book. Is there gonna be a math lady there? I can't afford to miss anything.